Artificial intelligence is doing some absolutely amazing things in medicine. We're seeing models that can spot complex diseases with an accuracy that can sometimes even beat human experts. But there's this one huge problem that's holding everything back, and it all comes down to a single word: trust. So to really get what that means and how we might fix it, let's just kick things off with a pretty wild question.
Just think about that for a second. Could a piece of software screen for a condition like autism spectrum disorder just from a photo of a child's face? I know it sounds like science fiction, but the tech to do this is a lot closer than you might think, and it brings us to this really critical moment.
Because on one hand, you have this incredible promise. I mean, some research models have hit up to 98% accuracy classifying facial images. That's astounding. But on the other hand, you have a massive problem. These incredibly powerful systems are what we call black boxes. We get an answer, but we have absolutely no idea how the AI actually came up with it.
So what exactly is this black box? Well, think of it like this. You feed a photo into one side of the box, and a diagnosis pops out the other. But everything that happens in the middle, the reasoning, the logic, the why, it's a complete mystery. And in a field like medicine, where actual lives are on the line, an answer of "just trust me," yeah, that's not going to fly.
It really all boils down to this. For a doctor to actually use a tool, they have to understand how it thinks. For a parent to trust a result, they need to know why the AI reached its conclusion. Trust isn't some nice-to-have feature. It is the absolute foundation of all healthcare.
So, how do we get inside that box? How do we crack it open? Well, that's where a new approach called ExplainNet comes into the picture. It's a system designed to do something pretty revolutionary, not just to make a prediction, but to actually explain itself in simple, plain English.
So how does this whole thing work? You can think of it in 3 steps. First, you have a powerful AI model that does what you'd expect. It looks at the photo and makes a classification, autistic or not autistic. But then, here's where it gets really clever. A second system acts like a detective. It creates this visual heat map that literally shows us which parts of the face the AI was focused on. And finally, a third part acts like a translator, turning that visual evidence into a simple sentence anyone can understand.
So this is the first piece of the explanation that the system gives you, the raw evidence. This heat map is the AI literally showing its work, pointing and saying, hey, I was looking right here when I made my decision. But, for a busy doctor, trying to interpret this is still a bit technical.
But here's the real game changer. The system doesn't just give you that heat map, it puts it all together. The prediction, a confidence score, and, most importantly, that plain English summary. The model focused on the mouth and nose regions. And just like that, the black box isn't so black anymore. A doctor can see the prediction, the visual proof, and the written logic all in one clear interface.
Okay, so the idea sounds fantastic on paper. But the million-dollar question is always, does it actually work? Well, the research team ran a pilot study to see if this whole pipeline, from the image all the way to the explanation, held up.
And what did they find? In this first test, using a pretty small data set, the prototype hit an accuracy of 80%. Now on the surface, you might think, hey, that's a really promising start, especially for a system that's doing so much more than just spitting out a label.
But, and this part is absolutely crucial, that 80% number is nowhere near ready for the real world. You see, the goal of this first study wasn't to build a perfect, market-ready tool. It was to prove that an end-to-end, interpretable system like this was even possible to build. And on that front, it was a massive success. A huge part of building technology that people can actually trust is being completely transparent about where it falls short. And this pilot study was perfect for finding those weak spots so they can be fixed.
So, the study brought a few key challenges to light. First, the data set they used was tiny, only 100 images, so you can't really generalize from that. They also found this weird issue where sometimes the AI's heat map would focus on all the right parts of the face, but it would still get the final classification wrong. And finally, that text generator, the translator part, it had some growing pains of its own. For instance, you'd get cases where the heat map would clearly light up around the cheeks, showing that's what the AI was paying attention to. But the text generator, which was based on a simple set of rules, was only programmed to talk about the eyes, nose, or mouth. This creates a real disconnect between what you see and what you read, and it's a perfect example of what they'll need to improve in future versions.
And digging into the performance a little more, you see another important detail. To put it simply, the model was more likely to miss a potential case of autism, what we'd call a false negative, than it was to incorrectly flag a non-autistic case. And for any kind of medical screening tool, making sure you don't miss cases is priority number 1.
Okay, So after hearing about all these limitations, the small data set, the 80% accuracy, the incomplete explanations, you might be sitting there thinking, so what's the big deal here? Why does this matter if it's not perfect? And that is a totally fair question. Because the big deal was never about the 80% number. The real triumph of this research was showing that it's possible to build a system that goes all the way from a complex image analysis to a simple, human-readable sentence. It was a successful proof of concept for a whole new kind of AI, one that doesn't just give you answers, but actually shows its work.
And that really leaves us with a fascinating thought for the future. For decades, we've mostly thought about AI in terms of automating jobs or replacing human tasks. But what if, by cracking open this black box, we're on the verge of creating something totally different? A true partner in diagnosis, one that's not just incredibly powerful, but also transparent, understandable, and ultimately, something we can truly trust.